Okay. For last problem, this is the solution. VL of t actually that is equal to 90 into 10 power minus 3 into 0.15 into e power minus something into minus 33.33 into 10 power 3. This minus 33.33 can also be written as 3000 divided by 90. It is this can be 3000 divided by 90. This 90 cancel with this 90, and if you multiply this 0.15 with this 3000, then we will get this minus 450 into this expression e power minus 33.33 into 10 power 3 t. It is for t greater than 0. So this is the expression of VL of t for last problem. Right. Another problem. So this is the second problem. In the network shown in figure, the switch is open for a long time and it closes at t is equal to 0. Find I of t. So this is I of t. I need to find this I of t for t greater than 0, and the switch is open for a long time. That means the switch is open for a long time and it closes at t is equal to 0. So the switching action is done at t is equal to 0, and at t is equal to 0 the switch is closed. Before t is equal to 0 it is in open position. So I need to find I of t expression. So how to solve this problem? Same procedure I am going to follow. At t is equal to 0 minus, I will draw this circuit. From that I am able to find I of 0 minus. That is nothing but the current flowing through the inductor at t is equal to 0 minus. After that I will find I of 0 plus. We know that the inductor doesn't allow the sudden changes in current. So whatever the current that is flowing at t is equal to 0 minus, the same current will flow at t is equal to 0 plus also. That is IL of 0 plus is equal to L of 0 minus is equal to I naught is equal to whatever the current that is flowing. So first let me find what is I of 0 minus here. So you see this is the circuit at t is equal to 0 minus. For this circuit, if I draw the circuit at t is equal to 0 minus by opening this switch here. So the switch is open here. Okay. Okay. The switch is opened here. So this is 10 ohm resistor, 10 ohm resistor, 10 ohm, 10 ohm, 50 volts. So it is I of t. Since it is at t is equal to 0 minus, it is I of 0 minus 10 ohms. It will act as a short circuit because it is under steady state condition from minus infinity to 0. So under steady state condition the inductor will act as a short circuit. So now this current will go like this because there is no path available to flow in this direction. Since it is open circuited, the current will prefer to flow like this. That means these two are connected in series. So this current is equal to I of 0 minus is equal to voltage divided by 10 plus 10 series 50 divided by 20, that is equal to 2.5 amperes. 2.5 amperes. So the current at t is equal to 0 plus also same current will flow through the inductor because the inductor doesn't allow the sudden changes in current. So I of 0 plus is equal to I of 0 minus is equal to 2.5 amperes. Now if the current at t is equal to 0, 0 minus 0 plus, the current at t is equal to 0 minus is 2.5, current at t is equal to 0 plus is 2.5. So there will not be any change in the current from 0 minus to 0 plus. That means at t is equal to 0, the current is 2.5 same. Now for t greater than 0, I am going to draw the circuit. From that I will write the integral differential equation. From that I am able to find the expression for I of t. So for t greater than 0, the switch is closed here. Switching action is done at t is equal to 0. T greater than 0, switch is closed here. Now the circuit will be like this. The switch is closed now, and this is represented with its equivalent circuit. that equivalent circuits will be equivalent circuit for inductor is like this. So this is I naught, initial current, that is I of 0 that is equal to 2.5 amperes. 2.5 amperes. Now it is 10 ohms, it is also 10 ohms. Now it is 50 volts. Now what I need to find this current? I need to find this current, that is I of t. So to find the expression for I of t, what I am doing here is I am going to simplify this circuit. How I am simplifying the circuit is using the source transformation technique. Use source transformation. Technique. This voltage source is in series with this resistance, can be converted. So this is voltage source. It is Vs Rs. It is A and B terminals, can be converted. Current source in parallel with the resistance Rs, the same terminals A and B. It is Is, and Is is equal to Vs divided by Rs. This is how we can find the value of Is. Rs is same as that of this one. Now use the same technique to convert this voltage source into current source. So now this is the current source. Now this Is is equal to Vs here is 50 divided by Rs is 10 ohms. Now this is here Rs is 10 ohms, so it is 10 ohms. So it is already here another 10 ohms is connected here. This 10 ohms, this 10 ohms is this 10 ohms. Now that is connected to this 10 ohms. It is I naught. Now this is the parallel combination. The parallel combination will gives 10 into 10 divided by 10 plus 10, that is equal to 5 ohms. Now this current source can also be converted into voltage source. The current source in parallel with this resistance can be converted into voltage source in series with this resistance. So now this is the current source in parallel with 5 ohm resistor. Now if you want to find the Vs is equal to, for this Vs is equal to Is into Rs. Use the same technique here. So it is voltage source, Vs is equal to Is here is, it is 5 amperes, 5 into Rs here is 5. Simplified circuit resistance 5, so that is 25 volts. Now what is the value of Rs? Rs you place here, it is Rs is 5 ohms. Already here it is 10 ohm resistor is there, 10 ohm resistance, it is 10 ohm resistance, and it is inductance, it is I naught is equal to 2.5 amperes. So this 5 ohm resistor, this 10 ohm resistance, both are connected in series. Let me draw the same circuit here. This is 25 volts. This 5 ohm resistance is in series with 10 ohm resistance. So 15 ohms, and here it is the inductance. Here it is I naught is equal to 2.5 amperes. Okay. Now this is the current. This is the current expression. Sorry, it is not a t is equal to 0 plus. It is t is equal to, for t greater than 0, this inductor, I need to place the inductor here. So this is the mistake that I did here. For t greater than 0, the representation of this inductance will be like this. It should not be open circuited. Okay. So it is, this inductance is like this. Now it is I of t, same current. The same current, here it is I of t. The same current, it is I of t. Now here it is plus and minus, it is plus and minus. So So this voltage for this is VL of t. Apply the KVL for this loop. 25 plus 25 minus 15 into I of t minus VL of t is equal to 0. Now 25 minus 15 into I of t, VL of t is L into di of t by dt. The value of L here is, L value is 0.1 Henry. So it is 0.1 Henry. So L value is 0.1 into di of t by dt is equal to 0. Okay. Now write this expression. 0.1 into di of t by dt plus 15 into I of t is equal to 25. So di of t by dt plus 15 into 15 divided by 0.5, that is 150, into I of t, 25 divided by 0.5, that is 250. So this is the expression. Let us assume it is equation 1. Now this is a non-homogeneous first order differential equation. So it is like